Welcome to the podcast. In today's episode, I speak with Kriben Govinder. He's an Aussie and he's an expert in gut health, microbiome. He runs two companies, one company that does stool testing and another one called nourishmeorganics.com.au, where you can get all your, the prebiotics and probiotics and all that kind of jazz. And in today's episode, I will be asking him tons of questions about gut, immune health, and light. So please sit back and enjoy. Welcome to the show.
Thank you for having me, Christian.
This is awesome because you're a food scientist. You work with the microbiome, the gut health, and I have quite a lot of questions because I'm supposed to be like a gut health guy, but I don't really know that much about it. I read a couple of books, poo and some stuff like that. So I would love to ask you some basic questions and then maybe some deeper questions.
I got to say, I'm really fascinated with the book called Poo. that must have been a very interesting read.
Yes, I was introduced to that by the girlfriend of our one of our team members a few years ago, and that's actually about the gut and how your poo is made and all the all that kind of stuff. So I'm interested in it.
Is that the Julia Enders book?
I think it's a girl, and her sister is a doctor, and she's a writer. I think it's a German girl who wrote the book.
I think it is Julia Enders. Yeah. I think it might be called Gut. Is it called Gut?
Maybe it's called Gut. Yeah.
Yeah. I figured the connection. So that was certainly one of the early books that I read as well. Fantastic book. Very, very easy to actually read in layman's terms.
Yeah. So I will start with, I'm a big believer in something called the trivium. And it's basically a way of thinking where you do the grammar and then you do the logic and then you do the rhetoric. So I would like to do some grammar exercise with you. So we hear about this word called microbiome. What is it and where is it?
Yeah, so the microbiome is it's all the trillions of bacteria, archaea, viruses, yeasts, fungi, protozoa. So it's all these organisms that live within our body. So in each different area of the body has a microbiome, but it also encompasses the genes that each of these organisms have as well. So it's an interesting one because in the media you hear microbiome, and then there's another term called microbiota.
Yes.
But the microbiome is just encompassing the genetic material as well, whereas the microbiota is just the organisms themselves, whether it's the bacteria, viruses, fungi, etc., etc. The majority of the microbiome in the human body resides in the colon. So a huge chunk of it is in the very lower part of the digestive tract. And it's just, through nature and evolution or creation or whatever you believe in, this is where the bulk of them live, and in that region of the body, it's almost like an organ that weighs around 2 kilos. So it's a massive, dense rainforest down there in the colon.
And what does it do? Why are they there?
Well, lots of things. Lots and lots of things. From a genetic perspective, I just mentioned the genes that these microbes have. Most of the genes in our body are actually from the microbiome. So there's 100 times more genes in the microbiome. Like years and years ago, scientists went through the Human Genome Project, and they thought they figured out, now we've cracked the code, we're going to cure all diseases and all that because we've worked out the blueprint of the human genome. But it turns out that, it's relatively a small number of genes in our own nuclear genome, and that's the genetics within our cells. But there's a much, much larger story because the microbiome, there's 100 times more. So from my research and what I'm looking at, I think the microbiome allows flexibility because they are expressing genes that then go on to produce all sorts of vitamins, nutrients, enzymes, They produce neurotransmitters that impact the brain. So they fill in a lot of the gaps for our own deficiencies. And the microbiome allows us to be very adaptive because it's very fast changing. So it allows us to go into a new environment and then very quickly adapt, because the microbes will change and the microbes will express genetically very differently based on the environmental stimuli and what we need at that particular time. And it turns out like one of the biggest drivers, I think the biggest driver is actually our immune system, but that's still a whole lot of emerging research that's going to go down that rabbit hole. But from the literature, scientists believe that the biggest driver is the diet. So imagine, going into a very almost like it's a good example now to use with the COVID-19 situation. Imagine if the whole world just goes pear-shaped, the whole supply chain shut down and no one's got any food, and we have to go back to hunter-gatherer type of lifestyle. So we're going to be trying to forage food and find food however we can, and then the microbiome will very quickly adapt to based on what is available in terms of berries and fruits and tubers. And if you're going to start fishing or hunting animals, the microbiome will shift.
Yeah,
So
but
that's
if it's so adaptable and shiftable, I guess the big problem is there a problem in the general gut health or microbiome health in the population? Or is it, as you say, it doesn't matter what you eat? Well, you say nutrition is important, but you also say that the gut microbiome can change and adapt very quickly. What are the effects of eating, let's say, a SAD? Isn't that the correct name?
yeah,
A SAD diet. Let's say I want to follow a SAD diet. What would you say could be the detrimental effects on the gut?
Yeah, the standard American or standard Australian or just a Western style of eating is very devoid of a lot of the nutrients I think that we used to get through our food supply in the past. And it's also gone from a very natural, clean eating style to more processed style of eating. So rather than eating fresh foods and fresh meat and fresh produce, we've actually starting to incorporate a lot more fast foods, processed, ultra processed foods that are very detrimental.
Why is that a problem? Why is that a problem?
Very detrimental to the microbiome, because a lot of the food additives that are added to these products are antibiotic in nature. So meaning that, whether it's from your water supply, which has chlorine naturally in it, around 5 ppm, which is the norm. Now that's a low level antibiotic. So it's going to have an influence on the biome. So it's going to shift the biome in a certain way because it's going to be killing off certain types of bacteria. And then the other problem is that when we eat processed foods have a lot of preservatives. But the way preservatives work is they're antimicrobial or microbial static, meaning that they kill off bacteria or yeast or fungi and other microbes, but then they also might stymie the growth. So they might stop growth. So again, this influx of antibiotics through the food supply is then having an impact on the microbiome in a quite unnatural way. But it turns out probably the biggest the antibiotic influence is actually coming not from the doctor, but it's actually coming from our meat consumption.
Yeah, that's what I heard. Like, I'm in Thailand, and we have these huge corporations that control the food supply, and even my local friends here say, "Oh, now with the COVID, you cannot eat the meat." I'm like, dude, I never eat the meat.
Yeah. The meat's a big problem. Yeah, I'm very familiar with Thailand because I used to be in procurement, so I used to procure a lot of. Like I used to deal with a lot of the big suppliers in Thailand in the seafood industry and the chicken industry and whatnot. But the issue is with the raising of farm fish, which is big in Thailand, or beef, which is big in countries like the US or even in Australia. The issue is that they use antibiotics, not so much for the health of the animal. They just worked out a long time ago that when they give the animal through its feed, a lot of it's grain feed and things like this, when they give that animal antibiotics, it makes the animal bigger. So it's a commercial reason why they add
Yeah.
antibiotics into meat, because the yield is better, because you're selling meat per kilo or per pound or whatever unit you're using, but it's all based on weight. So by feeding this animal a very low grade of antibiotic, it is making the animal more profitable. But the antibiotics are still within the meat when you consume it. So that's the big issue for us. Again, it's another insult to the microbiome, because it's shifting the microbiome in an unnatural way. And the issue with farm fish, which is prawns and things like that in Thailand, is that when you farm these fish, and I've had inside information coming through from these farm fish operations, these fish cannot survive without antibiotics. So from a farm fish perspective, prawns, I'm not too sure, but certainly for farm salmon, these fish can't survive without antibiotics. But
Yeah.
that
Norway.
antibiotics then,
I'm originally
sorry?
from Norway. I'm from Norway, so
Yes.
speaking bad about the
Yes.
salmon, it's like a cardinal sin and should be banned from all official. So yeah, it's like completely toxic, right? But in Norway, it was like,
Yeah.
no, this is, we make it down in South America. It's just because of commercial reasons. It's not because of lack of oversight or any. Okay, so gut biome is an issue. People are eating the wrong foods. So let's say now I want to fix my gut biome. I want to be better at it. I want to, what can I do? What are the different? I know that you're big on the, the kombucha and the fermented stuff and all that.
Mm-hmm.
So what can you do?
That's a good question, Christian, and it's a big question. But firstly, let's say the microbiome is like a fingerprint, so it's highly personalized to an individual, and you develop this fingerprint before you're even born. So whilst you're sitting in your mum's birth canal, there's interactions happening between the mum's biome and your biome, which is then starting to form into this organ. And then depending on how you're born, influences the initial seeding. So if you're naturally born, is very different to a C-section birth. For instance, a natural birth will result in more bacteria and microbes that are within the mum's vaginal canal.
Mm-hmm.
But that's now we're assuming that the mum has got a healthy vaginal microbiome. So this is how complex this is. And then a C-section baby is then going to pick up the microbes yourself. So they're going to pick up the microbes from the theater where the actual baby is born. So they're going to pick up things from the mum's skin. So that biome then looks very different. And then you go on to, how is this child then raised? Is the mum really pedantic about cleanliness, and is it really sanitary and, almost like a hospital type environment in your household versus, like parents that just put the kids in the backyard and they're rolling in the dirt and then they're playing with the pets. That child is going to have a very different microbiome. And then it comes down to, once the child probably gets past the age of, say, 3 or 4, then it's going to be more to do with what is this baby eating? Does the baby have a ear infection? They get a huge whack of antibiotics. So it's all these things that are then going to influence. And then we get to an age, and then someone might go off for a stool test and get the microbiome tested. And this fingerprint is then the result of this whole child's life to that point, which resulted in this particular microbiome. So, and it's like a fingerprint. Like I've had in my other side of our business where we do the testing side, I've had companies contact us for court cases with fecal samples wanting to identify a certain perpetrator of a crime. So this is how individualized the microbiome is. You can actually identify a person based on the microbiome genes.
But how can you do that if it changes so fast, if it's so adaptable?
Yeah. Yes. So there's different layers to that story. So from what we call our phylum level, like a phylum level is like a very high classification of the different microbes. You know, we'll talk about something like Firmicutes or Bacteroidetes or something like that. There's not that much difference, you know what I mean? Because they're broader groups. But as you get down to the nitty gritty, really finite levels, that like a subspecies strain level, then there's a lot of variation. But once the body reaches a steady state, it is always a steady state is like homeostasis. So the body's own immune system, once it reaches a certain state, whether it's a disease state or a non-disease state, the body is just trying to constantly push it back into that state, even if it's a disease state. Because a lot of chronic diseases will take many, many decades to develop. So we can still get very personalized information like a fingerprint, because the body's always trying to push it back to stasis. But from a subspecies level, just a simple meal will change your microbiome. So it's all to do with what level of identification you look at, whether it's phylum, genus, you know, all the way. So it's like phylum, class, family, genus, all the way down to subspecies strain level. So what you're talking about, Christian, is more variation and change in the subspecies level.
Okay.
But in terms of the fingerprint, you know, if we look at something like a genus level, it's going to be pretty constant. And because the mix of microbes are different, are so different in everybody, we can pinpoint a person based on a stool sample. So that's the
That's
reason.
pretty cool. That's pretty
Yeah.
cool.
So it's a long answer to the
No, but it's
question.
awesome. Yeah, I want to learn. I want to learn about this. But before we started taping, you said that no, I go outside naked in the sun. And I do the same. And my wife thinks I'm a little bit not so gentle to the neighbors. But does that have to do with general vitamin levels, or is that also connected to the gut?
Yeah, so we can add on to that original question that you asked me, like how do you actually make the improve or optimize your microbiome? So I gave you that definition of the microbiome and all these different factors of how it changes, and then how it actually is like a fingerprint. So using things like photobiomodulation, so sunlight. So that's why I'm always going out in the sun as much as I can. And the reason why I do that is because for my research and very emerging research, and if people in that science space and they want to read the papers, there's an amazing paper called, I think it's called The Rhythm and Blues or something like that. It's
Let's see if
written
you can
by
send me that link. I can put it into the
yeah,
show notes here.
it's a groundbreaking study. I mean, we've had hints of photobiomodulation, circadian rhythm, and its impact on the microbiome, but these guys are amazing. They're from the University of Cork, APC Microbiome. There's a couple of amazing researchers. I interviewed on my own podcast, Professor
Okay,
Ted Dynan.
I'll check it out.
Professor Ted Dynan is a beautiful man, really lovely guy. I met him in person in Paris at a conference as well. And another guy by the name of, what was his name? Ted Dynan, and it will come to me. But Ted Dynan is one of the authors as well. John Cryan. John Cryan's the other guy. So these guys wrote this paper about the impact of circadian rhythm on the microbiome, but from a psychological perspective, because these guys are looking at how the gut and the brain are connected and how it impacts mood. But in that study, they talk a lot about rhythmicity and circadian rhythms and the impact of that on the microbiome.
In what
The
way?
thing
Like
is,
you keep your own circadian rhythm, or that your microbiome has its own circadian rhythm and like has a sort of timing to it?
both. So the body has its own circadian rhythm. There's a section in the brain called the suprachiasmatic nucleus, which is the master clock in the body. So this is what sets the timing. And then all the cells, the peripheral cells, have their own peripheral clocks. So every cell has a different clock. But then the microbiome also has its own clock. So one of the keys to
Related?
modulate, all related, all connected. So one of the ways we can actually balance the microbiome and optimize the microbiome, aside from diet and exercise and all the mindfulness, all these other strategies, is to actually make sure that all these clocks are all lined up. And so one of the easiest ways to do is to actually yoke ourselves or connect ourselves to the light dark cycle. So it's really easy, it's simple, and it's free. You literally wake up in the morning with as minimal clothes as you can, you know, safely and legally do, walk into your backyard or go for a walk or something like that, with as much exposure of the sunlight, the morning sunlight, to the eyes and the skin and the gut. Because when this light hits the eyes particularly, there are all these chemicals called opsins that are in the skin and the eyes, and they are the ones that actually program the circadian rhythm.
So this is chromophores that, this is so cool. So I wake up, just to make it a little bit personal, I wake up pretty much the same time every day, because I also read a lot about the circadian, not only eating, but circadian rhythm and how it's important, but maybe more from a biohacking perspective where, because the body uses red light, or at least some kind of near infrared light, to communicate with itself, you need to have it super pitch dark. So I have the black tape over all the lights and all that stuff. But I thought that was primarily because of a communication issue. Will that also influence the gut if there's some light in the room, or is that a different mechanism?
Yeah, so what you're talking about then, because we talked about the light cycle. So I'll just finish off that loop and then I'll go to the dark cycle. So the light cycle is waking up in the morning, getting sun exposure. Then at midday, the midday timing is when you start producing vitamin D from the sun. So vitamin D has a direct impact on the gut microbiome and the immune system. So it's super important to actually allow this UVB light from the sun, which is only active around midday. So it's a very short time window that you have to let the sun actually shine on the skin to produce vitamin D, because vitamin D is absolutely critical for the body. And then we go into the dark cycle. So when it gets dark, when the sun goes down, that's when we can start using blue light blocking glasses to then allow the body to actually make melatonin. But melatonin production actually starts in the morning when you get the light exposure in the morning, because you make the precursors, and the precursors are called POMC. So the POMC then gets converted into serotonin, which is then it's a neurotransmitter that impacts how you feel and mood. We don't understand the mechanism yet, but serotonin is well known as a feel-good hormone. So you produce serotonin, but then serotonin then cascades into melatonin, which is the sleep hormone. So what happens when the sun goes down? We want to keep everything dark as possible, turning off the lights, make sure all the LEDs are off. If you're using screens, using blue light blocking glasses, keeping your sleep sanctuary pitch black as possible, using taping, or really not allowing that light from outside. It could be a street light or lamp that's then shining into your window. You don't want that light to get into your room, because it'll confuse the body, because those frequencies are going to be like telling the body it's in the middle of the day. So if you're sitting in front of a screen and you've got this really high intensity LED blue light, running from 400 nanometers to 490 or whatever it is, really sharp white blue light, that's going to confuse the hell of the body. It's going to be producing more cortisol and things like that, which is going to offset your melatonin. So you want to make sure that you're producing enough melatonin from all that POMC that you've generated in the morning. So then when you put your head on the pillow at, say, 9 or 10 o'clock, you're just going to be knocked out. And during that sleep time is when all the rest and repair processes go on. The healing of the gut lining, things like that. Gut cells turn around very quickly every couple of days. It's a very thin layer. So this is when the repair process happens.
And what I have noticed when I keep so I do the same. I wake up with no alarm clock. I have not used alarm clock for the last, 15 years. and I wake up because I go to bed relatively early, and I drink a big glass of water. And when I do this same time every day, I go
Yeah.
to the bathroom after like 2 minutes every day, the
Yeah.
same time.
Yeah.
So, and I
Yep.
have noticed one thing. Maybe you can explain why. It's hard for me to sleep in because I want to go to toilet at exactly the same time every day. What is that? Is that the
Yeah.
same
That's
circadian guy?
perfect. That's perfect. So what I teach people with circadian rhythm or circadian rhythmicity is that you want to be eating at the same time every day. So, and then, but you also want to be going to the bathroom at the same time every day. It's like training the body to be on a rhythm. That's what a rhythm is. It's like rhythm, you know, you're doing things on a certain beat or a timing. So it's the same thing. If you eat at the same time, if you go do number twos at the same time, if you sleep at the same time, everything is in check. And we know that when the circadian rhythm is off, it creates disease. All we need to do is look at the studies on shift workers, and we'll see that these guys are high risk for many different diseases. Even simply, you know, a person, it's a difficult situation now with self-isolation, but say in a normal situation when you're in a work schedule, you tend to do things pretty much at the same time because you've got to wake up for work, right? But at the weekend, you might go out for drinks at night, you might have a later night, and normally you feel like crap on Saturdays. Maybe there's some alcohol involved as well, which is another terrible thing
Yeah.
in excess for the microbiome.
I don't
So,
touch that shit.
but you can even feel it. Like recently we went through daylight savings changes. So daylight savings ended in Australia. So it's literally a 1 hour shift. And I noticed in my body, my whole body was out purely because of this 1 hour shift in timing. I actually ended up getting like some sort of gastro issue. And that was just purely because I'm so strict with my circadian rhythms. That 1 hour change messed up my gut.
It's crazy.
Like,
But
so
so
this
okay,
is how,
to say here, so you live in Australia and I live in Thailand. One of the reasons why I live in Thailand is because of the light, obviously because of the sun. So I'm from Norway and I grew up and I had the winter, not super, super hard, but I had the winter depression. With going around, go to work, come back, there's no light, and we evolved in light under the sun, right? So when we started Recharge, we actually started looking at pain management, like specific pain management and circulatory issues with the diabetes. But then, of course, we saw the whole gut thing because you're talking about the POMC.
POMC.
POMC,
It's
yeah.
it's an acronym for this long chemical, but if you
Okay.
Google POMC, you'll get the full name for it.
So here's my question. So, like my friends in Norway, that's not really an option to take your clothes off and wander out in your garden naked right now. And I see a lot, and we also talk about it on our blog, that you should use red light therapy on your tummy. But as
Yeah.
far as I understand, that will not produce any vitamin D because we don't have any UV in our. So that's for the midday stuff. But what I'm talking
Yeah.
about is the POMC, the gut, the healing. What do you think might be, why would you put red light therapy on your tummy, like specifically?
Yeah. So red light really ties in more so, I think, to mitochondrial function.
Yes.
So if you look at the gut, I mean, mitochondria is another fascinating topic because it's also mitochondria are actually, from this, what the science is suggesting, they are also a bacteria. So an endosymbiotic bacteria that maybe many billions of years ago embedded into a cell or was engulfed by another cell, but then became an organelle within the cell. So within each cell, there's anywhere between 1,000 and 10,000 mitochondria. But if you imagine those gut cells, so they have, say, let's say they have 1,000 mitochondria in there, but those mitochondria are then impacting how these gut cells perform. So the gut is actually a very, very thin layer. It's only one cell deep. If you pull out a hair, Christian, you cut it in half longitudinally, that's how thin the gut is. So the gut is actually the biggest interface to the outside world.
Yeah.
And then so you've got the gut, and then you've got two layers of mucin, which is mucus, and you've got 80% of your immune system sitting in there because it's the biggest interface to the outside world. Because if you take the gut and you pull all the surface area and lay it out, it's like a tennis court. It's massive. And that mitochondria, those mitochondria that sit within those cells are the energy producers in the cell. So they're the batteries. That's one aspect, but they are also the very early warning sensors. So they are the interface between our genomes. So the mitochondrial genome, again, is a separate genome. You got three separate genomes. You got mitochondrial genomes, you got nuclear genome, which is us, and you got the microbiome. So the mitochondria are like the conduit because they are a microbe, a very ancient microbe called an archaea. So they perform this kind of sensing abilities, but then they also trigger our immune system. So our immune system, we have all these different immune cells, B cells, T cells. They produce cytokines. We were talking about cytokines earlier. So you've got your innate immune system and your adaptive immune system. So they can either go and swallow something up, or they can adapt and produce antibodies to actually neutralize pathogens and things in the gut. But the reason why red light is so important is because studies suggest they improve the function of mitochondria. So I think, from my perspective, I think the secret to great gut health, or health in general, it's so underutilized, is mitochondrial function. Because if you think about this, if these cells, so these organelles within the cell, every cell has them aside from red blood cells. And red blood cells literally shuttle oxygen around the body. A lot of the red blood cell activity is to do with exposure to sunlight as well. But the reason why mitochondria is so important is because of this impact on the immune system. And I mentioned earlier as well, I think the biggest factor that drives the gut microbiome is your own immune system. So
sorry, I'll just ask a question again. So you were just saying that about 80% of your immune system is the gut lining.
Is within the gut.
Oh, so within the gut lining itself is not 80% of the immune system.
No, all these just behind that wall is where all the immune system is lining up. All these, these T cells, B cells, neutrophils, dendritic cells, all these cells are all there. They're all there because this is the biggest interface to the outside world. It's not the skin.
And also another question, and once again, it may be silly. So we eat food, it goes down the tube into the stomach. Is that the gut starting there, or does the gut start in the colon?
From the mouth. So all the way down.
Start here.
Yeah. So you got to think of yourself, think of a worm. A worm is horizontal. So a worm has got two tubes. So it's got the outer tube, which is the skin, and the inner tube. We're like worms. Just take a worm and put it vertically. So whatever's in the gut is outside the body. So it has to, like, think about a guy that's trying to smuggle diamonds. He swallows it, right, and then he poops it out because it's not absorbed into the body, because the lumen, the space inside the gut, is actually outside of the body. So what's happening when you eat something, it goes through all these gauntlets. Like, so there's enzymes in your mouth, there's, these immune cells in your mouth, then you have to go through the stomach acids, the bile acids. So it's got this gauntlet that it has to pass through to try and neutralize any threat. And then once it gets into the small intestine, then all the nutrients start getting absorbed out of your food. And then once it gets into the colon, then it's more the microbiome that's kind of breaking down and then helping further absorption of nutrients and water. So it's like, and that's why I think, in terms of immune function, I mean, it's so important for gut health to get the mitochondria working properly. And red light therapy is one of the best ways. Like, literally, the first thing is actually to just go out in the sun and expose yourself, because there's red light just coming from the sun itself.
That's the mother of all red light therapy.
It is the mother. Like, but if I'm in Melbourne in the middle of winter, when it's getting really difficult, right, to get that sun exposure. Red light's a pretty good alternative, especially, and I do red light therapy every day. So what I do is I actually use a machine and I hang upside down. So I do a bit of spinal decompression and red light therapy. So it's a combination of the red light and also near infrared light.
Yeah, that's
as
what
well.
that's what we use too. We use near infrared has an even greater potential, I think, for the mitochondrial effect in the tummy as well, because you need to go a little bit deeper, right? So the red light, maybe won't go all the way into the guys in there. So my science gal here, Sarah, she is currently working on a brain device, a photobiomodulation device for the brain. But the protocol that we're designing for testing this, and we're doing this with some quite high level professors and doctors in the UK, they insist on using light on the tummy and the brain. And they want to see the effects on not only Alzheimer's, but autism. Why do you think because we wanted to make a brain device for that, but what we hear back from the clinical side is that no, you have to look at both, because you can't really just start affecting here. You have to start here.
Yeah, I mean, there's mitochondria all over the body. So there's a huge density of mitochondria in the brain, because the brain is the biggest energy sucker in the body. I mean, it's huge amounts. So you're probably talking closer to those 10,000 per cell for brain cells, and certainly for heart cells as well, because those things use the most energy. So hence, maybe that's why these scientists want to look at enhancing the mitochondria within the brain itself.
Yeah, but I think so. We wanted to go for the brain, and they said no, because you need to influence the neurotransmitters that you talked about earlier, like serotonin, for instance, and dopamine, and that stuff. But then yesterday I heard another interview where a person said that but you have to understand, the serotonin produced in the colon is not the same as the serotonin produced in the brain. And I got a little bit confused, I have to admit.
Yes, we don't fully understand. It's still unknown whether the serotonin produced in the gut actually passes the blood-brain barrier. But 80% of the serotonin, 80-90% or something like that, is produced in the gut. The thing is to note is the gut is like a separate enteric nervous system, like it's different. It's like, that's why it's called the second brain. So it's connected via the vagus nerve. So
tell us about that. That's awesome. That's like a buzzword these days. What is the vagus nerve?
The vagus nerve. The vagus nerve is essentially your parasympathetic nervous system. So it's that rest and digest system in the body. But the brain, so it's this whole branch of.
Is it a thing, or is it like a concept?
It's a nerve. It's like a nerve. It's an actual nerve, like it's nerve fibers. So the enteric nervous system is like, this dense network of nerves that are in the gut, and they have as much intelligence as a small cat. So it's a really intelligent system. Like if you sever the vagus nerve, the gut will still function, because it's like a separate evolutionary tree or something like that. So the way the gut and the brain communicate bidirectionally, so whatever happens in the brain then signals down to the gut, and then gut to brain. But there's a lot more communication going from gut to brain than the other way. So a lot of these neurotransmitters like GABA, like acetylcholine, IPA, dopamine, serotonin, and others are all produced in the gut. So, but the gut mitochondria are probably they're the fastest turning over. Like aside, probably the eyes would be another set of mitochondria that turn over really quickly. But a lot of dysfunction.
Why is that? Because they get tired, worn out?
No, because they have to. Because the gut is such a thin lining, these cells need to just turn over. So you've got a new gut every couple of days. So they just have to, because they're just getting smashed. So it's just the biggest interface to the outside world. So hence they turn over so quickly. that's why maybe these guys want to look at the gut as well. I certainly shine a lot of, when I do red light therapy, I do a lot on the gut as well. And then the other reason why
What
I'm
do you
not
hope
sure.
to achieve? Why do you do that? What's your thinking behind it? Tell me, like from your perspective. Okay, why should I shine the red light on the gut? Exactly why you do it.
I think from my understanding, I think the red light actually penetrates quite deeply. So it is getting down to the microbiota. So
Near
there are,
infrared will for sure.
yeah, yes. So it is getting quite deep to impact the microbiota. So that's why I do it. The red light, I do it more so because I want my mitochondria to function optimally. My understanding, a lot of this is very early days, and like guys like Gerald Pollack are doing work on the fourth phase of water and easy water and all those things. But there's suggestions that the red light actually helps with the production of exclusion zone water. So,
Yes.
which then, from my understanding, again, this is really fringe science. Like, I mean, there's not that many studies out there. We're really talking almost like hypotheses. But my understanding is that easy water is not as viscous. It's like 10 times less viscous than regular water. So this is going to help a lot with that proton gradient in the mitochondrial function. You know how there's the electron transport chain?
Yeah. So yeah, I'm
all
actually
that kind of stuff.
last month he came out with the audible version. So I'm listening to the fourth phase of water now. And Sarah, she went to see him at the University of, where is it, Wisconsin or something. So we have talked to him about it, and that's one of my questions too, or was one of my questions, how you think you can influence the easy water, which is, I guess you can. I don't think that's fringe. Easy water is not fringe. Easy water is totally, that's science.
It's science. It's science, but I think it hasn't fully reached the mainstream adoption. So hence I'll say it's still early days. But it is, easy water is definitely, from my perspective, is definitely a thing. Like I'm behind Pollock's work for sure. So
Yes.
I think anything that can help that ATPase spin more efficiently is going to help, like, system wide. Because
Yes.
really cells are just a combination. Sorry, organs are just a combination of cells. So if all these mitochondria are performing a lot more optimally, it's going to certainly help the organ perform as a whole,
Yes.
whether it's the gut or the brain or the heart, the eyes, wherever they are. Mitochondria are at the crux of optimal health, that from my perspective.
Yeah, I think so too, and that's why I'm so psyched with recharge and the red light stuff. But let's see here. I wanted to talk about something called photobiomics, but I'm guessing that's pretty much the term of what we have been discussing so far, or is it
Yeah,
photobiomics, some like a specific different thing?
I think it's exactly what we're talking about. It's really the impact of light on a biological system. So we are tied to the sun. There's no argument from that. We need the sun to live. Without the sun, we won't live. But the emerging science and the literature is all going into things like quantum biology, chronobiology, photobiomodulation. All these things are just ways to describe how light impacts the body. We know light impacts, the secretion of cortisol and other type of hormones, when they secrete, the timing. So it's all interrelated. So the light cycle is definitely important. From my perspective as a food scientist, I'm really interested in how this light impacts things like insulin and blood sugar. And we know blue light triggers the production of, raises blood sugar. Like
Yes.
10 years ago, if you told someone, if you are eating your meal under blue light at night, it's going to make you fat, they'll laugh at you, right? But now
Yes.
this is science. Like if you are sitting at night under a bright blue light, eating your food with raised insulin, what does insulin do? It triggers the production of,
Yeah.
the creation of or storage of fat. So sitting under blue light is making you fat. And that's a fact. But
So cool.
and again, this hasn't reached mainstream adoption. This again is fringe science, but it's factual, right? It just hasn't hit the mainstream. Most people just don't know about it.
I think I live in the bubble. I think maybe we are sort of in the similar bubble, or because for me it's like, huh, really? That's fringe? I thought that was pretty.
Yeah, that's what I mean. We live in a bubble because we're in that kind of, that space where we're watching the science really closely.
Yes.
But I tell you, Christian, most people would be absolutely clueless. And most people would think you're crazy to suggest something like that. So,
okay, so here I have a question, which is more of an actionable, more of a like a real life thing. So once again, I'm what you can call an expat. So I didn't even have the pleasure of going through the birth canal. I was, given to this world through a C-section. And then I was born in Scotland. And after year one, I moved to Norway. And then when I was 20, I started working in Asia, and I moved to China when I was, just before 30. And now I live in Thailand. And you're saying that what you eat and where you come from, or sorry, what you're saying, your genome, your epigenetics from when you're born in the first year and two. But here I am in Thailand. Is that danger, or can I expect to have a lower immune health or lower efficiency of my gut biome because I have completely changed my location?
well, your genes were really only responsible for maybe the one of the top guys in the nuclear genome space is a guy, Dr. David Sinclair, and even he says in his research probably genetics only account for like 20%. So it's only a very small part of the story. So I think as long as you are practicing, all these fundamentals that we spoke about, like very clean diet, watching circadian rhythmicity, avoiding processed foods, all that kind of stuff, I think you're going to be perfectly fine, because your body now has got this GPS signal that's then yoked you to the sun. And I think you probably need to look at your other side of your genetics, which is your mitochondrial genetics, and look at your haplotype. So look at haplotype. So the mitochondrial haplotype is very different. And there's been a lot of conjecture on, where do you get this mitochondrial DNA from? There was a paper that literally just came out like weeks ago. Like there was all this conjecture on, no, there's also some influence on the dad, influencing the mitochondria. But now I think it's the latest study that came out is saying, well, it's pretty much from your mum. So what you have to do is look at your mum's haplotype. So you can look at you can get some sort of gene test done, but look at your mitochondrial haplotype and then try and match to that haplotype. So depending on where your mum's origin, you've got to trace your mum's right back to where your mum came from as far as you can go back, and then try and adopt some of those habits and lifestyles that those type of people would be adopting.
So let's say that's not super easy. I have no idea where my mom's came from.
It's pretty easy. With a gene test, you'll find out pretty easily. It's not that.
And you do that kind of stuff. Is that you can
No, we don't do it. But there's other companies that can do your sequencing. But once you work out your haplotype, for instance, myself, I'm a HV2 haplotype. So when I trace it back, my ancestry from my mum's side is coming from somewhere in Persia. So it's probably in the 30s type latitude, although probably high up in the mountains. So, with mitochondrial haplotypes, it's whether you're coupled or uncoupled. So you're sitting in an equatorial zone,
yes,
which is probably going to lend itself better to someone with a coupled haplotype. So I would be doing, if I could purely guess with your Scandinavian background, and I could be 100% wrong, but if we could guess that somehow your mother's mother came from somewhere in the Vikings or somewhere in Norway in the mountains, I would guess that doing something like a lot of cold thermogenesis would be beneficial for you.
And I do. That's so cool because I do ice baths. My kid, I have a 13-year-old boy who wants to be the world's best Fortnite player.
Yeah.
Of course, I want to support him in his quest of becoming the world's best Fortnite player. And he had a friend who did ice bath, and he said, "Daddy, I also think I want to do this ice bath." And I have some friends who are coaches. I'm like, "Okay, boom, okay, Wednesday, boom." So he couldn't get out of it, and now we do it every week. And yes, it works really, really well.
Yeah, I'm the same. I have an uncoupled haplotype, so I do ice showers every day or cold showers, and I jump in the ocean as much as I can. So even in the middle of winter, it could be like 8 degrees Celsius, I'll be jumping in the ocean.
Wow.
Because that really helps me. It's all to do with, again, mitochondrial function. So it just helps when the mitochondria uncouple, they produce infrared heat. So again, it's a nice hormetic stressor to just get those, keep challenging those mitochondria, especially to burn fat to generate heat. So it's a nice, easy way. And you look pretty lean, so you're doing the right thing.
Yeah,
this is how you keep really lean.
So what we do, we do first the ice bath, and then we go out to the mother of all red light therapy products and sun for like 15 minutes, and then we go inside.
Yeah,
I have to admit, if we don't have the sun, it's too cold.
Yeah, I think it's good. Yeah, I do the same. I do cold in the ocean, in a sauna, couple of rounds sometimes, hot, cold. Does make it easier.
That's very hippie of you, sir.
It's so good for your mitochondria, though, because, these, again, in this modern society, we've just gotten too used to having this constant thermostat. We're not challenging the body. I mean, circadian rhythmicity as well, one of the biggest drivers is temperature. So that's another way the body actually knows what time of day it is just based on temperature. So if you got your thermostat set at the same time, so the same temperature throughout the whole day, again, this is a massive circadian cue that you're missing out on. So it's better just to go.
How about aircon? So I work in Thailand. So right now I turned off the aircon because we're recording, but I'm starting to get a little bit hot. So normally I have the aircon on like 26 in daytime. Will that have a negative impact? Because I don't do that all year.
Yeah, I think in your region, we've got to be practical as well. I mean, you probably need the aircon, but it's good that you're challenging yourself anyway by using your cold therapy. So it's not like it's constant for you. You're still going out in the sun.
Yes.
There's still a hormetic stressor. But for most people, they set that thermostat and there's no shift. Do you know what I mean? There's no cold showers. There's no ice therapy. There's no walking in the sun. It's just in an office the whole day, the same temperature. You go home, it's the same temperature. So you're missing out this massive circadian cue.
Cool. You know what, Kriben? I would like to say thank you so much for this talk. I could go on for like 3 more hours, and I want to talk to you again because I have just before we started, I was talking to Aryan and I showed him your bio, and he's a huge kefir, coconut kefir guy. My other friends are kombucha people. My wife makes kimchi. We have like 4 or 5 different species of kimchi that we make. And we wanted to talk to you about machine, making a coconut kefir, for instance, like actually machines, because that's what we do. We make things, we get things made. So I want to talk to you about that one day.
Yeah, sure. Happy to, man. Happy to. Have you checked out Nourish Me?
Yeah, of course.
Side?
Yeah, that's where I saw the, so nourishmeorganics.com?
Yeah, .com.au.
.com.au. And do you ship outside of Australia, or is it?
We do. We ship global.
Ooh. And you mentioned you have mushroom extracts there as well?
Mushrooms, we do sell 4 Sigma. But we're also looking at some other products.
Here in Thailand, they have a lot cordyceps and reishi and chaga.
Oh, okay.
Yeah. So there's some companies up here in Chiang Mai that does freeze drying and have quite a good production line. But I guess you are the person that can verify that.
Yeah. I might have to come up to Thailand sometime.
You're more than welcome, dude. I mean,
once all this isolation stuff finishes, of course.
That's right. Yeah, because I haven't really noticed the isolation. I have a little three-wheel electric tuk-tuk that I drive 5 minutes to my house. And so I haven't noticed. I go to bed before the curfew starts, and I. So sorry, I forgot about it. Kriben, it was great having you on, and thank you so much for telling us all that cool stuff about gut health.
My pleasure. Absolutely, man.
So have a great afternoon. Sorry, I'm not so experienced in the Zooms. Please continue.
No, it's okay. I was going to say, if people want to check out some of my stuff, so you can always find me on obviously www.nourishmeorganics.com.au. My Gut Health Gurus podcast as well, where I actually talk to all the scientists, like the guys that are actually doing the research in all these topics that we're talking about, the lead scientists. Because really my aim, it takes 17 years from a scientific paper to adoption in the medical industry and the mainstream. So I really want to try and shorten that time span as much as I can to actually get the researchers' information into the audience a lot earlier so that they can start to adopt this amazing information. Like imagine Pollock's work, things like that, that are still at the university stage, or things like Professor Ted Diden's work on circadian rhythmicity. That paper only came out a couple of months ago. So who wants to wait 17 years, right?
Yeah, I completely agree. I completely agree. And I have checked out your podcast. I downloaded it. I have subscribed to it, and I will recommend it, and I'll put it in the whatever show notes or how we're going to make it. And I really think and it's so cool when I saw you on LinkedIn there, like, dude, I want to talk to that guy.
Yeah. And if people want to reach out to me, I mean, the best way to reach out to me is Instagram. I'm probably the most active. So if people just search on Instagram, YouTube, Facebook for just Gut Health Gurus,
Gut Health Gurus.
I'm not the guru. So Gut Health Gurus, I called it because it's all these amazing scientists. They are the real gurus. I'm just the facilitator of the conversation.
Awesome. Yeah, thank you so much, and have a great afternoon, and good luck with your evening sunshine.
All good, man. Thanks, Christian.
Have a good day. Ciao.